So now that we've gone through all these calculations, we can calculate our optimal risky portfolio. The one thing we do need to do here is make an assumption for the risk-free rate. We'll use a risk-free rate of 3%, which is the same number that they used in the slides. So the weight in bonds is simply the market risk premium for bonds, that's expected return on bonds, minus the risk-free rate, multiplied by the variance for stocks. And then we subtract market risk premium for stocks, so expected return on stocks, minus the risk-free rate. Then we multiply that by standard deviation for bonds, multiplied by the standard deviation for stocks, multiplied by the correlation coefficient, which all of this is equal to the covariance, return on stocks, and return on bonds, which is the last thing we calculated. You'll note down here we have the same number. So I'm going to write out the full form here. So this is be 5 minus 3. The variance for stocks, 347.1. This is a minus. So, and this is 10 minus 3. And then the standard deviation for bonds is 8.27 and 18.63, and then minus 0.49. So that's the numerator for this equation. And I'll show you in a minute how to simplify this. So we've got 5 minus 3 times 347.1 plus 10 minus 3 multiplied by the variance for bonds, 68.4. Then we subtract the market risk premium for bonds plus the market risk premium for stocks. And then we're going to multiply that by the standard deviation for bonds, the standard deviation for stocks, and the last item is the correlation coefficient. These calculations much easier if you have a spreadsheet or a graphics calculator works really well as well. So that number is 0.66, and I'm sure a whole lot of numbers behind it. So the weight in stocks is just 1 minus 0.66, or 0.34, some numbers beyond that. We can simplify the equation by just doing a couple of calculations first. So we can calculate the market risk premiums. So market risk premium for bonds is 5 minus 3, that's 2%. Market risk premium for stocks is 10 minus 3, that's 7. So we can redo the calculation. The weight in bonds is simply, we've got 2, our market risk premium for bonds, multiplied by the variance for stocks. Then we subtract market risk premium for stocks of 7, and we multiply that by the covariance, minus 74.8, and we divide. So we got 2 times 347.1 plus 7 times 68.4. Then we're going to subtract our two market risk premiums. So we got 2 plus 7, and we're going to multiply that by the covariance of minus 74.8. And again, that should give you 0.66 and something. So finally, we can calculate the expected return on this portfolio. So that's 0.66 multiplied by the, and you should go ahead and use the whole number here. So save that number and use it in your calculation. So multiply that by the expected return on bonds, 0.34 multiplied by the expected return of 10% on stocks, you get 6.70%. So we can also now calculate our portfolio variance as well. Okay, so now we can calculate the portfolio variance. So sigma squared P is equal to the weight in bonds. That's 0.66 multiplied by the standard deviation for bonds, 8.27. We square that, plus the weight in stocks multiplied by the standard deviation for stocks. And then we've got 18.63 squared. Then that's plus 2 times the weight in bonds, 66. And then the weight in stocks, 0.34, sorry. And then we multiply that by our covariance, 74.8. So multiply those out, add them up, and you should get 36.39. So the portfolio standard deviation is simply the square root of 36.39, and that is 6.03%. So now we've created a portfolio with an expected return of 6.7% and a standard deviation of 6.03%.